I want to talk to you about a slightly different perspective. We've heard a lot about architecture and components of different frameworks. I want to see how could we actually use these to build something, and what do we need to be able to do that? Well, I think the word FaaS and serverless can confuse some people. And you might have seen this diagram before, this picture. I guess today, most of us are probably on the right-hand side. But there may be people here that are on the left-hand side of this diagram. And I don't know if you've ever had this conversation with somebody where you explain about a project that is FaaS, and they say, we're not ready for serverless yet. So what are you building? We have containers and Kubernetes and microservices. And so I think there's some kind of disambiguation that we need to go through to show that there's more to serverless than FaaS. Right? So we'll start with that, and then I'll show you the Plunk stack. So these are cloud-native projects. We'll look at what each one is and how it can be used. Some case studies of what people are doing with it today, and then there's a few ways that you can respond. So I always find it helpful to kind of go back to this example, particularly because it's quite simple. We have a huge monolithic application and a database and a client. The reason why we've probably moved away from this is because the change domain here is potentially unbounded. Every time we want to make a change to our application, we could have a knock-on effect to anything else that's within it. And when I worked at ADP producing payroll applications, we could take up to 6 months to cut an entire release, or a patch might take 2 weeks to test. There are other problems that Docker helped us solve, where we were able to package our code in containers and know that we had the same code in every location. And so I think if we look forward from here, we end up splitting things down, and those responsibilities become smaller. We don't have to worry about the change domain quite so much. So in the pet store, we now have a purchase function and a search function. That might even be a microservice. The authentication doesn't have to be something that we've written. It can be something that we buy in, or a service that we make use of, like AWS Cognito. And we can even have an API gateway, whereas before we might have had to have relied on IIS or building that ourselves. Now, if you squint at this, at KubeCon, I could show you this, and you might say that's a Kubernetes architecture. And if I showed you this, maybe at AWS reInvent, you say that's a Lambda architecture. And that's what I want to try and get across, is that they're so similar that I think we can do very similar things with them. So Kubernetes is probably undoubtedly where we want to be running this kind of workload, because we're at KubeCon. But the popularity of Kubernetes with developers has really peaked. I think we've got around 10,000 to 11,000 people at this conference alone. But that's not the only interest. Actually, there's top-down interest as well. So imagine us here, maybe the developers and PMs, the bottom-up interest. We also have the C-suite that's heard about it, and for whatever reason, whether it's from analyst relations, or maybe they're even quite technical, they're used to code. They're like, okay, adopt Kubernetes, let's be cloud native, it will fix all our problems. And it turns out that it's not always that simple. There's some advantages you can get from lift and shifting. So let's look at it from both perspectives. From the developer side, we've got this declarative API. It's really extensible, and it's so extensible that the community is extended beyond what Kubernetes has even designed. I was listening to Tim Hopkin yesterday telling us about ingress route and these plans that VMware and Heptio have had to kind of rethink that and make it more multi-tenant. It's built to scale, and there's a very rich ecosystem. You see a picture of the cloud-native landscape, and it can be a bit off-putting, but those are all projects that we can actually use to build our stuff now, rather than having to do it all ourselves, as before. Now, businesses can benefit from the open governance. So this project was originally created at Google, as we know, but now it's at a place where people can be held to account, and that is very important for some companies. It's portable, so we can run that in different environments. Gartner recently changed their multi-cloud advice from deploying to multiple clouds at the same time to using Docker containers, because they give you a level of portability. And because it's used in production, that means there's companies that are ready to stand by you and support you. So there's 100 ISVs at the moment. There's probably more as of this week. And you can pay them to help you support your software in production. Okay, so great reasons on both sides. But I think there's still a little bit lacking in the middle. So it's great for our platform engineers, great for the business, but the application developers, perhaps the background that I had at ADP where I was creating applications on a daily basis, they probably don't want to be getting into the low-level details. Don't know if anybody's ever used the LAMP stack. Do you remember what it stands for? Yeah. Linux, Apache, MySQL, PHP. Yep. And when I first used that, it was great because I think there was an installer, there was one thing that I put on my computer, and I was cutting code very, very quickly, and I could take that to a VPS and effectively run it in production. We've got some slightly more modern stacks now, LAMP and, Mean and Jam. But I want to look at a stack that can allow you to write in any programming language, a bit like what Eduardo was showing us. So this Plonk is an acronym. It includes Prometheus so that we know what's going on with our applications, we can observe them. And these are all cloud native projects apart from OpenFaaS is not part of the foundation, but the others are. Linkerd is great for when you're working with microservices and there's certain properties or behaviors that you need from the network. Again, Istio is an alternative that you may use there, but if you're not ready for that, we don't have to be pedantic, we could just swap that for Linux, so that's why that's up there. OpenFaaS gives us a platform, a RESTful API, CRDs on Kubernetes where we can go and deploy microservices and functions very quickly. NATS is the current default asynchronous processing bus, and that means that you don't have to design your own queue system. Nobody should have to do that in 2019. And then Kubernetes, we all know why that's there. So I'll give you a real example of an application that we wrote. I did this with a contributor in Japan, and it took us about a day asynchronously. And it records the activity of your GitHub repository, or your organization. What we're looking at is the issues that have been opened and comments that have been made. You may say that you could measure GitHub activity through commits and pull requests, but this is trying to look at it from a slightly softer angle, something that shows a level of engagement. So the architecture for this, if you think to the pet store that I showed you and how we broke everything out, it's very similar again. Up at the far right, we've got the user who would come and try to get to the dashboard and simply serving up a static HTML page using Vue.js. That will make a request back to a function called leaderboard, which executes our stored procedure. And we've got a relational database that we're not having to host. Someone else is hosting it for us. The bit that I like is the event-based part at the bottom. So the contributor, when they make the action, GitHub has a pub-sub relationship, and it will send to a microservice the payload. We check that it's actually from GitHub, and then we'll do the insert. And so it's obviously not actually real time, but in something very close to that, we can be tracking the activity, and we can build a system out like this. Okay, so that's a real example of the Plonk stack. Now, to look at each project, Prometheus is something that you can use whether you're interested in serverless or not. You probably already have a good idea about what it does. It's a time series database, and we want it so it can observe our system and be able to ask questions about how it's doing. That's very important because we've got these containers spinning up and down and many services. As an example of PromQL, which is the language you can write in, this is also available in other time series databases like InfluxDB. It can be quite difficult to get your head around when you begin, but we're just looking at the rate of invocations over a minute that went okay. Now, the other thing that you can do, because this is a time series, is you can ask a question in time, and you can either look at where we are today, or you can go back over, I think the retention period is 1 to 3 months, and see how things were going. And so that might be useful if you're rolling out a new version of your code, or perhaps you just want to know how things are going. Now, I was chatting to somebody came up to me this morning from Optum, and he said, we've been using OpenFaaS in production, And we basically built these webhook receivers as functions. And so when we have various Prometheus alerts that go out of band, so we may be getting too many errors, we execute that code and we try and remediate it automatically. And this is an example of what you can do with Alert Manager that's part of Prometheus. Now we're using it for something slightly similar in OpenFaaS, which is to scale the functions or services. You can also use HPA from Kubernetes if you prefer that, but this is just turned on by default. Let's take it a step further, being able to integrate the metrics from Prometheus directly into the API such that we can tell you how things are going. And you'll see other projects do that. Linkerd ships with its own version of Prometheus, for instance, and they use those metrics in their dashboard. So if you were wanting to use this, whether you're interested in serverless or not, you add a metrics endpoint to your application. You'll then be able to get HTTP data very, very quickly. They've actually got code in the SDK for that. We can start listening to your own kind of messages. So perhaps we wanted to see the GitHub organization as a counter and see who is actually committing code or commenting. And then you can trigger alerts. So that's what Alert Manager and Prometheus can do for you. And this is a graduated project, which is the highest status in the foundation. The other one that I wanted to mention was Linkerd. And again, the guy from Optum came up to me this morning and said, well, we're using Istio with OpenFaaS, so both are fair game. And what you might want to do with this is to shift traffic between versions. I think this already came up earlier today. And the basic idea is that you may not want to have a new version of code and have all your traffic go to it at once. So without changing the OpenFaaS API, we were able to use this and just create simply two functions and then another one with a primary name, and we can change using the SMI spec how much traffic is going to A or B, which is really useful. Mutual TLS isn't something that necessarily everybody is going to need up front, but originally in the 90s, it was okay to have our security up to perimeter, up to the firewall. If we want to start looking at zero trust networking, perhaps we're doing payment processing, when you think about encrypting traffic over the wire, and this, again, is something that you can turn on very easily. Now, the insights we had from Prometheus were good, and they're built in, but we can get more than that. We can start to look at the TCP connection level, and Linkerd can help you debug that. If you want to know a bit more about how the two projects can work together, there's a talk on Wednesday with Charles from Buoyant. I'll show you a link at the end. So OpenFaaS, which is the O, started in 2016, and I think much like the story that we heard from Azure, I had been using Lambda and basically cloud functions and wanted a way of being able to run this on containers. That was my basic goal. And lots of things have changed since then, and the project at the moment I think is still the most popular by GitHub stars on the landscape. But the reason for that, I think, is down to the values of the project and the community, which are to try and put developers first so that it's very easy to create new functions, to deploy them. There'll be a CLI that's intuitive, a command line, and a UI. To be friendly for operators so that, yes, perhaps you will want to use Kafka in production and that's going to be your use case, but maybe not everybody needs that. Maybe there's something we can do to get you started quickly or allow best practices to be embedded within the code. So there's a Helm chart with least privileges and many of the things that we can do so that when you try it out, it's a good experience and a positive one. The community is really, really important. There's 250 contributors at the moment and 2,000 people on Slack, and they're pretty active. Somebody joined the community recently and completed 3 huge features over the course of a week. And so that just shows how important the community is. We're always doing things to try and involve new people. Now, part of the reason that I created this originally was to try and move away from some of the constraints that I'd seen building applications in the enterprise and then coming to serverless in the cloud and finding that things were different. So if I was an Amazon customer, then I'd be building a zip file out and trying to somehow compile my dependencies if they were native against the version of Linux that Amazon were running in the cloud. If I moved to Google, I had to completely change that process. And and I might have different regions available, different maximum file sizes. Just didn't really seem to fit very well with what I knew using containers. And also, it's very difficult to lift and shift a microservice into this pattern. Right? So in the enterprise, we can actually get something that's more portable. Now, I've been calling this Serverless 2.0, and I think I've heard a few other people use this term as well. We think of that cloud serverless, the SaaS, purely hosted, where you can have an argument whether it's really serverless, if it's a paid product or not. Any code means that you can have this new kind of workload rather than the zip file that's specifically for Amazon or specifically for Google. We can have a new type of workload that we can run anything within. We can take it to any cloud because of Kubernetes and then scale down to 0 if we need to, or scale up as necessary. And the only way we can do that is by inventing something new, which is a runtime contract. So before, the runtime contract was specific to each cloud, and now it becomes a Docker image that is stateless and listens to HTTP traffic on a given port. If you can provide a container like that, it turns out most code can do that, then you can host it in OpenFaaS, in Knative, and even on Cloud Run. Right? And so what I'd like to see, and what I'm hoping to see, is that more of the projects that we've talked about, like OpenWhisk and Kada, will start to adopt this format, and we'll be able to actually take this, and if we want to move away from that idea of FaaS, we can just run this on Kubernetes anyway. But it's actually pretty hard for a developer. So what would we have to do to get Hello World? Well, probably going to start with index.js if we're using JavaScript. Then we want to put our middlewares in there. Package.json, you always have to have a package.json. You then want your handler, service definition for Kubernetes. This is getting away with it lightly. This is a deployment YAML file with some health checks in it. And then we've got our ingress, and we can't forget about that Docker file. Now, after all of that work, you can say hello world on port 8080 on Kubernetes, right? And I think there's probably some things we can learn from what we've done before. Some people have compared serverless to CGI bin, right? But we just do it a bit differently now. Object-oriented programming has 4 pillars. Those are encapsulation, abstraction, inheritance, and polymorphism. Through the function store in OpenFaaS, we're able to take a container that you've built out through your pipeline, whether that's an API or machine learning model, and make that discoverable. People can then take that encapsulated function, run it locally, and make use of it in their code. You can even have your own store at work. Abstraction allows us to take, and I'll show you what this will actually turn out like, all of those YAML files and the Docker files and entry point, and make a very simple template that someone can pull in or write their own. I guess the closest thing we've maybe seen is a build pack before, Cloud Native build pack. And then with inheritance, we're able to take perhaps Docker layers and make sure that we're only shipping the last part of the code that we've changed. In terms of polymorphism, this is that serverless definition where you have an API, a static website, a microservice, or a function, but because they all conform to that same definition, we can treat them like an interface, and that allows us that portability. So this is what you would have instead. Right, so we had all of those files. I think they count up to 300 lines of text, which is probably okay if you've got one, but if you have 10 or 100, it's quite hard to maintain. This is what you get instead, and it's very similar to the Azure definition that we saw, and there's a very small YAML file. Within that, you can set environmental variables, secrets that are predefined, memory limits, and labels. And that's really all there is to it. So we can go from 0 to production in probably 5 minutes. We take this code, and it finds our IP address. It's written in Node.js. We could just deploy that to Kubernetes. Now, when you start to install these projects, even if they're relatively easy to do one, it turns out that because we don't want to reinvent the wheel with each project, we want to use what's out there. With OpenFaaS, we want to use something like Nginx, Cert Manager, OpenFaaS itself, and then have a certificate. That was about 5 pages of instructions, even though it was super simple. So I created a CLI called Ketchup, and it allows you to just wrap Helm charts and pass in strongly typed variables. So we could run this, and 5 minutes is probably an exaggeration, we'd have a production-ready system with a TLS certificate. Right? But I do want to try and show you the basic experience for bringing up a function. So I've deployed a cluster earlier using those settings, and what I'll do is I'll set my OpenFaaS URL. This is a gateway. I'll then create a function and copy and paste this text in. You can see here that I've done FaaS CLI new and put the language that I want. That brings it in from the template store, and we have this code that we'll enter in. And then there's simply one command once we've installed our dependencies, which is up. Okay. And remember, we're using containers, so we see a container build. Hopefully that's not surprising. And then the layered system means that we're only shipping the deltas. So I built this earlier. And we'll have that endpoint up and running, and we'll be able to go and visit it. Once it gets pulled down from the internet. And so we've got the IP address and status taco. Right, and if we wanted to iterate on that, it would be pretty easy to do so. So with this Ketchup tool, you can now automate the installation of this, and perhaps we'll add something for Istio as well. And then you can just simply run FaaS up like I did there, and you'll have a production endpoint you can give to somebody. Now, if you want to create your own, you would do FaaS CLI language, whatever, Node 12, Golang middleware. If you want to use Dockerfile, that's fine as well. This will generate your code, scaffold it. But all of those files we saw earlier, those big files, they still are there, but you don't have to worry about them because the template is maintaining it for you. And so the handler, i.e. the bit on the far side, will be combined with the template at build time. And then we'll get a Docker image that we can put in a registry, we can deploy that, and that's where you'll have a URL. Now, the other way that you can deploy stuff is through CRD, but you still need to build your function. Once you've built it and pushed it somewhere, or you have a pre-existing Docker image that conforms to the serverless definition, we can simply go FaaS CLI generate, and that will give us a CRD. You could use Flux or GitOps basically to be able to deploy that. And if you are a Knative developer and you want to try using the user experience of the templates, you can just with generate, and you can get a Knative serving definition as well. I wanted to give you a quick case study. This is my friend Ed. Someone said that people aren't using serverless within financial processing. Ed's working at a payments processing company in the UK, and he actually likes this thing called faster payments, and I don't know that we have it in the US. This is where I can send you $100 and you'll have it pretty much instantly in your account. And companies like Monzo and Revolut are pushing the boundaries on this. He also likes platform engineering, he likes Go, he likes GitHub as well. But he doesn't like the change advisory board. And what this means is there has to be a quorum of stakeholders to approve any change into production. And unfortunately, Jira is also on that list. So today, what happens is this a very sort of bread and butter workflow. PO, product owner, comes up with a new requirement. Developer picks it off the backlog, works on it. Great, we've got an artifact. And then we need to deploy it to production. And the current process was to use Jira, have those stakeholders log in, and then approve as necessary. But it was very difficult to see if it was ready, it could be error prone, and you had two disparate systems because the pull request was on GitHub. Now what he did is he used Plunk, and they're running this in production now. And so all of the approvers come along and they simply approve the PR through the GitHub API. Each one sends a webhook to the gateway and to his code, and when he's had a quorum amount, they will allow it to be deployed in production. So we were able to get rid of Jira, at least for that part. The other case study I wanted to look at is from Channing Connor over in the front row. Thank you for writing this. We've been able to generate a montage from a video, and this is a kind of use case you might see at a streaming company, such as Netflix, for instance. You may be wondering, well, did he write it in Node.js? How did he put this together? Well, actually, he wrote some bash, and I thought this was great. He has this bash code, pulled the template, FaaS CLI up, and now he's got bash over HTTP that's auto-scaling with metrics, and you'll see in a minute that you can do even cooler stuff with it, like connecting it to events. Now, Ed at Form 3, they use AWS SQS for a lot of their eventing, and so they built a event connector, we call it, and you can build your own event connector too. What you do is put together your function in your CRD or in your stack YAML file, and just add an annotation for a topic you care about. So in this example, we want to email a customer if we've got a topic called onboarded that's fired off. You just deploy a function, deploy a connector, and then they will invoke the function as necessary. Another example case study is Viber, and I know we have Mark Peake in the back from VMware and some other folks that have joined recently. This is my friend Michael Gash, and what he's been able to do is extend the functionality of a closed source proprietary product called vCenter that manages VMs, such that when a VM is powered on, the event can be observed and trigger a function. The use case that NVIDIA had for this was they had 12 different servers that were coming online and provisioning VMs, and they wanted to tag them. And so using the vCenter connector and OpenFaaS, they're able to achieve that workflow. Right. So it's just an example of what you can do once you've got a microservice or an API. Now, the other project in Plonk is NATS, and again, this is an optional one. At the moment, it runs at asynchronous bus, and this is great if you want to do messaging between microservices or you're looking at streaming data. The new version of NATS has a global network that you can tap into, which is really pretty cool. And then you can use it for command and control with IoT. When we apply it to a use case, let's take Vision Banco from Paraguay. They generate customer banking statements as PDFs. The request comes in through the gateway. It will then read the data from Postgres and upload the result to S3. Pretty simple. But this can take up to 2 minutes, and so the customer will be sat there with a spinner. What we're able to do is very simply, without changing any code, have that run asynchronously. And so using a different route, the code will be ingested into a queue worker will pick it up when there's capacity, and then the thing that's particularly useful here is being able to pass in a callback URL. So you can say, when you're done, I want to know here what the result was. And so then we can go off and email a customer, for instance. So you don't have to change your code at all. You just change the route. And whether that's a microservice or an API or FFmpeg, it will work the same. So some of the Plonk Stack users have talks from KubeCon, and you can go and find the videos on YouTube. One of the companies at the moment I think is interesting is DX out of Norway. They have a large ticketing system across the whole of Scandinavia, and they're selling tickets for events. They wanted to lift and shift a monolithic application written in Laravel and PHP, and they were looking to use OpenFaaS for that. They also have a pattern called the Strangler pattern that they're implementing, where they're cutting pieces of the code off and rewriting it in C#. And that's one end of the spectrum. At the other end, we have Vision Bank I showed you, but then also LivePerson, and LivePerson have integrated OpenFaaS into their conversational chat product, and they allow customers to extend their chat experience with customer reps by being able to write code. So remember the Prometheus alert that fired off if we had too many errors, they can actually fire an email off to your manager if you had a bad rating from a customer. And what I think this shows is that we can use Kubernetes for both sides of these use cases, right? And it can be great for both. We don't have to pigeonhole it to FaaS. When it comes to CI and CD, if we may run 3 or 4 minutes into lunch, I don't want you to feel bad if you use Jenkins. I actually think that sometimes coming to KubeCon can be like a bit of an echo chamber if you feel like you're not on the latest technology. All you need is to build a Docker image, and if that makes sense inside your business or your corporation, then go ahead. But one of the things that we found is that teams like BT and Citrix and Vision Bank, when they adopted OpenFaaS, they went about building their own pipeline, and that was actually stuff that we thought we could do for them. And so new users can just come in like DX and immediately have a pipeline ready, up and running, and not have to build that out and be so repetitive. I'll show you what it looks like. This is called OpenFaaS Cloud. And what we'll have is a completely managed system. So if you're particularly technical, but maybe your team isn't, you guys can benefit from having access to this sort of platform. What I've done is I've created a quick Node.js function and one using a Docker file because I said we can use Docker files. All we do is a git commit and a git push. And then within a few moments, over on my GitHub page, for my KubeCon repo, we'll see the code has been pushed up, and there's a bunch of commit statuses that have appeared, and we hit details. We'll see that those functions have already been built and deployed. That entire process of pushing and putting into production has run. We've got container logs that have come back, and we'll have live endpoints. So the one that runs in Docker is giving us a calendar in Bash. That's what I asked it to do. And then we have the other one written in a node. So you do not have to be an expert in Kubernetes. You don't have to build your own pipeline. You can actually get started very quickly. Now, somebody else touched on this earlier about Kubernetes not being for developers. I think it is for developers, but there's probably 2 categories. There's the application developer and the platform engineer. For application developers, it probably isn't suited to them because it's so highly configurable, it can be confusing to know what to do. The declarative API doesn't quite work how we're used to using systems as an API developer. We're used to calling Stripe and registering a new client, for instance, not setting a destination or a compass track point. And the eventual consistency can be really confusing too, right? This idea that you may get the events out of order. So there are sharp edges and there is a steep learning curve. When I learned this, and I don't know where you are on your Kubernetes journey, I did struggle with all of this. I think I'm a little bit better with it now after a few years, but I kind of remember what it was like. So just to sum up, the layers that we end up having are container registry, because we're building containers so that it's the same everywhere. And so we have that portability of the serverless contract. We can run in Knative, we can run on Cloud Run. Kubernetes allows us to go between clouds very easily. We get the same experience on our laptop as in the cloud. On top of that, we have OpenFaaS in the gateway so that we can build these services out and deploy them, whether through CRD or REST, and even auto-scale them using Prometheus. And NATs can allow us to run things in the background. So I think that Plunk is actually easier than, at least for application developers, than doing all that on your own. There's actually Unix that set this precedent of convention over configuration. Right? And Kubernetes sort of went the opposite way. It doesn't mean we all have to suffer with that. Sane defaults can actually be really useful in getting you up and running. So you probably do want a non-root user. You probably do want a read-only file system. We can set that up ahead of time, and then if you need to customize it, then it's up to you when you need to pop the bonnet. That does make things more maintainable using templates rather than having to have those 300 lines of YAML for every service. We can abstract and use those OOP principles. And then finally, this is something that has got a great developer experience because it's being built by an open source community, and it is used in production by the companies that I showed you. Right. So here's a few ways you can get connected, and I won't keep you from lunch any longer. You can join Slack. You can try out a free workshop where you can see what I showed you and go a bit further with it. And then there's another KubeCon session this afternoon with Ramiro. He's going to show you how you can accelerate building those containers, make them even faster than it was when I did it. And then on Wednesday, come and see the Linkerd session. It'd be great to have you there. So thank you very much.